Yeah, the most important problem or concept of terrestrial magnetism is the question for that. In the magnetic meridian, in the magnetic meridian of a certain place, of a certain place, the horizontal component of Earth magnetic field, here it is common. The horizontal component of Earth's magnetic field is 0.26 Gauss, capital G in the sense Gauss, and angle of dip, angle of dip is 60 degrees. What is the question is that what is the magnetic field of the Earth? What is the magnetic field of the Earth in that location or in this location is a question. Now, what are the given things? First, we need to write the clearly. It is understanding that whatever till now we discussed the concept, from that only it is. But we need to write BH equal to 0.26 Gauss and theta equal to angle of dip 60 degrees. What is the angle of dip? It is a angle between the horizontal component of the earth as well as resultant magnetic field, right? This is only no we studied as a delta till now.
Yes, sir.
Okay, now this is BH equal to d cos theta. This is dv vertical component equal to d sine theta. What we need to find? B we need to find. So I'll write this is BH equal to B cos theta equal, okay, 0.26 Gauss. Gauss is CZS unit system they have given. So we no need to use another term. So I'm continuing with the CZS system. B equal to 0.26 Gauss by cos theta, cos 60 degrees. Okay, can I write like this?
Yes, sir.
0.6 by cos 60. Cos 60 is 1 by 2, right? So 1 by 2 is 2 into 0.26. It gives us 0.52
It two.
52 Gauss. This is a magnetic field in that location. This is a magnetic field in that location. Okay. Now, same way, if we go with the another problem, is it understood now?
Yes, sir.
The next question is that if the horizontal component of Earth's magnetic field, if the horizontal component of Earth's magnetic field at a place where the angle of dip where the dip angle of dip is 60 degrees is 60 degrees is 0.4 into 10 to the power of minus 4 Tesla. means BH and angle has given, comma, calculate, calculate the vertical component, calculate the vertical component, vertical component and and resultant magnetic field, magnetic field at that point, at that point or at that place. Now, may I know what is the difference from the previous question and this question? In the previous question, we found magnetic field. They have given BH. Now also they have given the BH equal to 0.4 into 10 to the power minus 4 Tesla, and even angular dip also given 60 degrees. But here we need to find BV as well as resultant magnetic. So first, let us find at that place what is the magnetic field. Then we can able to find horizontal component and vertical component and resultant also. First, to find this, we have one concept. What is that? BB equal to, or in terms of tangent angle, the relation between the BV and BH. Look at here. From the triangle only, this is B, this is BH, sorry, BV, this is BH. Now, with respect to this, tan delta equal to tan theta, whatever is angle we have used, vertical component by horizontal component, right? So I can write BV equal to BH into tan delta. Can I write like this?
Yes,
So
sir.
BH is what? Is given the value. That is 0.4 into 10 to the power minus 4 Tesla into tan delta, tan 60 degrees. So BV equal to zero point 0.4 into 10 to the power minus 4 into tan 60 value,
Um, like,
sine by cos, sine 60 by cos
yeah,
60,
root 3 by 2 divided by 1 by 2. So, root 3, sir.
root 3.
Yes.
Forgot?
And no, I just had to think a little.
Root 3. Yeah. So if you do more numericals, then we will have in red. Zero point 0.4 into 10 to the power minus 4. Root 3 value, any idea?
1.732.
Okay. 1 point. Root 2 is 1.414. Root 3 is around 1.4 in the sense. It's approximately 1.5. Root 3 value. Use calci and tell me. 1.42 it comes.
I remember something like 1.7. Not sure.
Should be sure. Root 3 equal to 1.7. I expected.
Yeah, 1.732.
1.7 into 0 0.4. 0.692. 0.692 into 10 to the power minus, where we are? Yeah. 0.69 to 10 to the power minus 4 Tesla. This is a vertical component. Now, vertical component we know, horizontal component we know. The questioner asks one more thing also to us.
Resultant
This one,
magnetic field.
resultant magnetic field. So we know the formula BH square plus BV square means square of horizontal component and vertical component. Now zero point 0.4 whole square plus 0.69 whole square. Now 10 to the power minus 4 both cases common. If I'll take 10 to the power minus into 10 to the power minus 4, 10 to the power minus 4 common, 4 to the 8, 4 to the 8. If I'll take out, what it will be 10 to the power minus 4 only, no?
Yes,
Then we have to do with the zero point 0.4 into 0.69 square. 4 4 the 16. How much? Zero point 0.4 into zero point 0.4 gives us
1 point, oh no, 0.16.
what?
Uh, 0.4 square.
Yeah, I'm asking that only.
Yeah, so 0.16.
0.16 and 0.69, 0.47. So 0.16 plus 0.476 plus 0.16, right? 0.6361. 0.6361. So this is if you do under root, it gives the answer 0.79. 0.797 into 10 to the power of minus 4 Tesla. That is approximately equal to 0.80 into 10 to the power of minus 4 Tesla. But when you do like this, it feels the the value is heavy and calculation is heavy. But one more method is also there to find. You know that, like from the previous question, B equal to sorry BH equal to B cos theta, right? Or B cos delta. Therefore, from this B equal to resultant magnetic field at that place, B equal to BH by cos delta I can write. So B equal to BH how much better? 0.4 into 10 to the power minus 4 Tesla. By cos delta means cos 60 is 1 by 2. 2 into 0.4 will become 0.8, right?
0.8.
So,
This is so simple compared to the
uh,
other one.
but at times this is also may comes into the picture if horizontal components has not given or vertical components has not given or they both has given they are asking us to find this. Okay, so
Yes,
with the different angles it comes, then we have to come to this. This is so simple, but finally we have achieved the truth. See, there and here we achieve the same value,
yes, sir.
right now? So,
Yes, sir.
matter here to understand. So, mostly these base numericals can come 2 marks in the exam. If 2 mark questions are available for us in any exam or like if they make any comprehensive questions for us in that case they may ask such type of questions, right? That
Yes,
is the case of terrestrial magnetism based numericals. We won't have that Coulomb's law based numericals because it is actually out of our region, but still
so can
we
you please tell in the reader like which all pages won't be coming? So I can just mark it like what to study and what no need to go through.
Simple beta. I'll tell you that in magnetism, in this lesson, we have to read only this terrestrial magnetism and the terminology of magnetic moment, magnetic dipole moment, and Gauss line magnetism. These things are important in this lesson. And one more thing, coming to hysteresis. Actually, hysteresis has it's removed since what is that types of magnetic materials has removed. Hysteresis, but still it is required to understand the materials and in the next lesson about the transformer and all. But we need to have or study the hysteresis loop. Okay,
Okay,
it
sir.
is removed. Actually, how they have removed, in physics, the problem is that these people has removed the syllabus is like a DTP operator is sitting and he has removed like that. Is not subjective person has removed from there because if
Oh,
subjective person remove no, then he will remove a complete concept. Now what happened? This magnetic materials removed, okay, fine, but hysteresis is one concept which is related again in electromagnetic induction and all in other cases. So in that cases, the next things we are not able to understand if we are not studying that concept,
okay, sir. Yeah.
right? So
Yes.
few things, not all the cases it is. For example, they have removed in the nuclear physics all topics by some, and in semiconductor physics half of the lesson has removed. It's not a problem in such cases.
Okay,
Okay.
sir. Yes,
Yeah.
okay.
Now, one important question regarding the magnetic moment, which we uh, discussed just now, on that based. The question is that, yeah, an electron, this red color is better. An electron moves around a nucleus in a hydrogen atom. Moves around a nucleus in hydrogen atom. Now, which is having the radius r, excuse me, 0.51 angstroms, the radius of the hydrogen atom here, with a velocity of 2 into 10 to the power of 6 meter per second. Now, calculate or find question 1. The equivalent current due to orbital motion of the electron means current produced by this rotating electron or equivalent current due to orbital motion of an electron. Just now I have told in the case of terrestrial magnetism how magnetic field acquired by any material because of the motion of the electron only. So this is that one evident numerical. The current due to orbital motion of an electron. If current produces what? Magnetic field produces perpendicular to that. Question number 2. The magnetic field produced at the center of the nucleus. See, the magnetic field produced at the center of the atom or nucleus. Nucleus. Next, question number 3. The magnetic moment associated with the electron. The magnetic moment associated means obviously since it's the electron is revolving in a sense it produces some magnetic moment with electron. Now, first question in this part. What is that? Current due to orbital motion of an electron. Means this type of model question we have done earlier. Since this is a nucleus in the sense around the nucleus in the hydrogen atom on orbit, electron is revolving. Since electron is revolving in the sense it is moving, it is completing one cycle. So we know that basic current definition I equal to charge per unit time E by T. 1 by T is in the sense is a time function, right? So E means electron which is revolving. Okay. Now E I am keeping as it is time T equal to I can write uh, or 1 by T equal to what I can write velocity by displacement I can write, right? Here the displacement along the circumference of the circle that is 2 pi r, right? So what I will do now in a place of t, if I'll substitute that, how it will be if I'll substitute v will become velocity will go up, right? 1 by t,
Yes.
and denominator you are having 2 pi r. E means electron charge 1.6 into 10 to the power minus 19. Velocity has given 2 into 10 to the power of 6. Next 2 into 22 by 7 or 3.14 radius, which is given how much? 0.51 angstroms into 10 to the power minus 10 meter, 1 angstrom equal to, in terms of meter I am mentioning. So if you simplify this, how much you will get? This is 2 into 10 to the power 6, no? 2 to get cancelled, and 3.14, this is 1.6. 10 to the power minus 19 minus 10 will go minus 9 left plus 6 from minus 3 left. So I have above 1.6 into 10 to the power minus 3 by 3.14 into 0.51. Got it?
Yes.
Now, how we will minimize further? If I'll remove 31 and 16. Okay, this decimal, if I remove, here one more, 31.4 and 60. And 16 1 the 16 2 the 16 2 the how much? 32. Huh? So approximately I can take this. Then I have 2 into 0.51. 2 5 are 1. 1.2. 1.02. So I have 10 to the power minus 3 by 2 into 0.51. How much it gives us? 1. Means since it is having the decimal, 2 0.51, 2 into 1, 2 5 are 10, 1. So 1.02, nothing but you are having in the power of minus 3, 1.02. Okay, so nothing but it gives us 1. Approximately you are having here, you can write 10 to the power minus 3 amperes. Can I?
Yes.
10 point, okay, if I take up 10 to the power of minus, just a minute. 10 to the power minus 4 we can take up here. Because if I remove this decimal, then here 4, 10 to the power minus 4 amperes. Next, second one. What is the second one?
The magnetic field
Magnetic
produced.
produce at the
Yes.
center. See, this resembles, second question is resembling, uh, what is that? Magnetic field at the center of the circular loop, which is having the radius r. What is that? B equal to mu naught I by r. I by r or mu naught I by how much? Formula. Mu naught 4 pi into 10 to the power minus 7. I 10 to the power minus 4. 2 into radius 0.51 into 10 to the power minus 10. Okay, minus 10, minus 1, minus 4. Cancel, cancel here. And I have to 1 jar to 2 jar. Therefore, T equal to 2 pi 1, 2 pi into 10 to the power minus 1 by 0.51. Set. How can I write further this? 2 into 3.14. 34. How can I write 3.14? 6.28 by 0.51. How much it gives? 6.2 at 620. So 6.28 into, sorry, 0.51 is 12.3. 12.3, and at the same time we are having 10 to the power minus 1. So can be written as in terms of 1.23 Tesla. Okay, here it is approximately 10 to the power minus 4 amperes, and this is 1.23 Tesla we can write down. Next, the third thing, the magnetic moment associated with the electron. What is the magnetic moment? Formula M equal to I into A. What is the I? Is a current, 10 to the power minus 4 which we found. A is the area. Area is how much here? Area how much? Area of the circle. I mean here atom, no?
Yeah,
Circle.
so 2 pi r square.
2 pi, no. Pi r square area cross section.
Yeah, yeah. Sorry, pi r square.
Okay. So 10 to the power minus 4 into pi r square. So better, this 10 to the power minus 4 is a current, no? I'll write current EV by 2 pi r into pi r square. So easily we can do calculation. R square cancel. So you will have that E 1.600 minus 90 V. What is the V value was given in the question? 2 into 10 to the power of 6 meter per second. No? By 2. 2 1 jar, 2 2 jar. Then we are having magnetic moment equal to 1.6 into 10 to the power minus 13. How much units? I ampere meter square is a magnetic moment. I into A. Right? This
Yes.
is one important concept which we get as a numerical. numerical. And next, we have further concept to discuss here in this lesson in the next class.